JEE Main 2025 24th January morning shift chemistry first one strongest oxidizing agent of the given EU plus 2 CE plus 3 CE plus 4 EU plus 4. So this is kind of memory only. CE plus 4, this is the previous question also, so you can remember, and E naught of CE plus 4 by CE plus 3 is positive, so it is the strongest oxidizing agent. The difference in melting point and boiling point of oxygen and sulfur can be explained by atomicity, because oxygen diatomic gas, sulfur is octatomic solid. Ribose present in DNA is a pentose sugar. It is not in the pyranose form. Its alpha anomeric carbon is not present, so these two are wrong options. It is present in a D configuration, and its reducing sugar is a reducing sugar free form. That is the right statement. So right statement, correct as it is statements of NCERT. Ksp of CrOH taken thrice is 1.6 10 to the power of minus 30. Solubility product of water, solubility in water is 1.56 10 to the power of minus x. What is x? So CrOH taken thrice is AB3 type of salt. So Ksp is equal to 27 s to the power of 4. By solving like this, you can check this. Pass, check. X is equal to 8. Most stable carbocation is, okay, now there should be more resonance. In the first option, you see here, because of this oxygen, the lone pair of oxygen is participating this side also. So not much available for our carbocation. But here plus charge is there, and this is completely giving, so full supporting. Fluorine minus a worst, here nothing is there, so no special. In these two, this is better. But he asked about the more stable one, so maximum resonance is there. Most reactive towards nucleophilic addition. Most reactive towards nucleophilic addition means when we have aldehyde ketonic group like this, when oxygen is gaining the electron pair, carbon gets plus charge. If this plus charge is unstable, that is more reactive. So that becomes unstable by electron withdrawing groups at ortho and para positions, so NO2 is best. A to C, this is from physics I have taken. A to C, electron jumping from A level to C level, and 2000 angstrom is the wavelength. A to B, how much he is asking. B to C, if it is 6000 angstrom. So simple formula, 1 by lambda is equal to 1 by lambda 1 plus 1 by lambda 2. This we are taking from E is equal to hc by lambda. This is energy. E1, this is E2, and this is E3. So E1 is equal to E2 plus E3, or hc by lambda 1 is equal to hc by lambda 2 plus lambda hc by lambda 3. That you can cancel and you can get this. But this is given in physics, okay? In H2O, ammonia and methane, all central atoms are sp3, right statement. Dipole moment of water is more than ammonia, least for methane, because methane's dipole moment is 0. Ammonia in water is basic in nature. Ammonia is Bronsted acid, and H2O is Bronsted base. This you cannot say. Okay, NH3 plus H2O gives NH4 plus OH minus. So here ammonia is base, not acid. So that's a wrong statement. Bond angle water, ammonia, methane bond angles are given correct. So these statements are right. Paper is not so easy, moderate paper only. Most reactive till now, okay now. Most reactive towards aqueous HBr is, again same thing. When you are adding H plus, it is going to gain the electron and it is going to form the carbocation. If the carbocation is going to be stable, then that is more reactive. So this is more stable because of oxygen attached immediately, donating electrons by resonance. Okay now. All the at the freezing point of water, process is non-spontaneous. At boiling point, it becomes spontaneous. Means at low temperature non-spontaneous, at high temperature spontaneous. In that way, delta H is equal to positive, delta S positive is good. The relation is delta G is equal to delta H minus T delta S. He is saying at high temperature it is going to be spontaneous. Okay, now think in that way. And high temperature means T delta S value is going to be completely, it should be more than delta H. Then in that case, the delta S should be negative and delta S should be positive. In the preparation of KMnO4 from pyrolusite, the product after reacting with KOH, something is mentioned. So he is asking about the first step, that is K2MnO4, NCERT, as it is statement. Dumas method is used for the nitrogen test, right statement. Statement 2 is, in Dumas method, Nitrogen is converted to ammonium sulfate. Wrong. It is converted to pure nitrogen gas beta. Fe plus, this is one very good question which I liked in this paper. Fe plus 2 plus Ag plus gives rise to Fe plus 3 plus Ag. So here if you write the cell, that will be like this. So RHS minus LHS we write reduction potentials. Reduction potential is given as X for silver, that is fine. But for this is not mentioned. That you need to calculate like this. Fe plus 2 to Fe, that is given as Y. Fe plus 3 to Fe, that is given as Z. So Fe plus 3 to Fe, 3Z because 3 electrons are involved. This is we are calculating. This is Fe plus 2 to Fe, 2Y. So this change is equal to 3Z is equal to A plus 2Y. Let us say this is A. So A is equal to 3Z minus 2Y. And this is the cell RHS minus LHS. RHS is X, LHS is A, X minus. So one very good question of this paper. Simple but little bit logic. Here alkynes with water addition, that forms acetone. Then hydrogen cyanide addition, that forms cyanohydrine. Then reduction, that forms amine. Simple question. In Dumas method, which gas is evolved? I think that question only. Maybe students are saying it's a bit different, nitrogen gas. So they generally don't ask two questions in a paper about Dumas method. 10 moles of CO and 10 moles of Fe3O4 are mixed, and what is the amount of iron formed? From the equation, 1 mole of Fe3O4 requires 4 moles, and both are given here 10 moles. That means if you are taking 10 moles of Fe3O4, you need 40 moles of CO. But you are given only 10 moles of CO, means CO is going to be the limiting reagent. And 4 CO gives 3 Fe, then 10 CO gives how much? That is 30 by 4 moles. 30 by 4 moles into 56 is nothing but 420 grams. This is benzoic acid. How many grams of benzoic acid will give you 11.2 liters of CO2 at STP when reacts with NaHCO3? So the equation is very simple. 1 mole of this gives you 22.4 liters of carbon dioxide. 1 mole it is going to give. And 122 gram is the molecular mass of this. When 122 grams gives 22.4 liters, 11.2 is given by how much? That's simple, 61 grams. How many of the following shows characteristic colored precipitate with K4 FeCN6? Cupric, Mn plus 2 and Fe plus 3. Ferric ferrocyanide is Prussian blue color. Cupric ferrocyanide is chocolate color. And Mn plus 2 also forms colored precipitate. Choose correct solvent. Here you see OH minus is there, here R3N is there. This is primary, this is primary. Both are primary means both reactions are SN2 reactions. Means in both cases you need aprotic solvents. Okay. Thank you. This is Lucky sir.